Lesson 2, we're going to be talking about simplifying and writing algebraic expressions. So I'm going to start by giving you some vocabulary. In algebra, a term is considered to be a product of numbers and variables. So variables would be things like letters. For example, 3x squared y is a term. It's a product of letters and numbers. And that 3, that number, is referred to as the coefficient of that term. Like terms are defined to be terms with the same variable part. And that would be the exact same variable part, has to have the same exponents as well. So the first thing I'd like you to be able to do is identify like terms. Again, like terms have the exact same variable part. So which of the following are like terms? Well, part A, they both have x's. Those are like terms. But in part B, we see different exponents. One of them has an a, the other has an a squared, and so those are not like terms. Part C, these are like terms. They both have the exact same variables, x and y, and there aren't exponents. Part D, those are also like terms. They both have x squareds. It doesn't matter whether your coefficient, your number, is positive or negative. Part E, those are not like terms because they have different letters or different variables. And this last one in part F, these are actually not like terms as well because notice that one of them has an x squared, the other has just an x to the 1, and then the other one has a y versus a y squared. Now, why do we care about like terms? That's because if we want to add or subtract algebraic expressions, we'll be doing something called combining like terms. To combine like terms, you add the coefficients, and the variable part stays the same. When it comes to adding or subtracting algebraic expressions, we are only allowed to combine like terms. We cannot combine terms that are unlike. So let's take a look at an example. In part A, these are like terms. They both have x's. So to do the addition, we just add the numbers. 11 plus 7 is 18. And the variable part doesn't change. It's 18x. Same idea in part B. We add, well, in this case, we subtract the coefficients. 5 minus 10 would be a negative 5. And then the variable part stays the same. In part C, we've got some pairs of like terms. The 6a and the minus 1a are like terms. And then the 4b and the 12b are also like terms. We can add or subtract, now in example C, I have some like terms and some unlike terms. In other words, I see both a's and b's. And it doesn't matter what order the terms are in, because we can actually add in any order we want. So the first thing I need to do is think of this as an addition problem. In other words, that minus a is actually the same thing as a plus negative a. And you don't have to write down this intermediate step if that makes sense to you. But the idea is I can combine the terms with the a's and then combine the terms with the b's. So I have a 6a and a minus a. Now, if you don't see a number in front of the variable, you can actually think of it as there's an imaginary 1 in front of that variable. What this actually means is we have a 6a and then we have a minus 1a. We don't write down coefficients of 1 because if you take 1 and you multiply it by anything, it doesn't actually change the value. And so that's why we don't actually write those ones down. But when you don't see a number in front of a variable, the coefficient is 1. So 6a minus 1a would be 5a. I add the coefficients, the variable stays the same. Then I have to combine the b's. I've got a 4b and a 12b. And so if I add those two, 4 plus 12 is 16. I get plus 16b. I can't go any further with this problem because the a and the b aren't like terms. They cannot be combined. So to add or subtract variables, we can only combine like terms. When it comes to multiplication, you can multiply in any order you want. So this 3 times 4x means we've got a 3 times 4 times x. And so we just multiply the numbers together. 3 times 4 is 12, and that becomes 12x. The same with part B. We've got a negative 3 times 2 times y. I just multiply the numbers together, and I get negative 6y. This is true even if you have a product of 3 things. You can multiply in any order you want, which means I can multiply the 5 and the 3 and then the negative 4 and just put the x at the end. And in fact, that's what's standard, is to put the variable at the end of the term. So let's see, 5 times 3 is 15, and then we've got 15 times negative 4. That's definitely going to be a negative. I think that's negative 60, and so my answer is negative 60x. But the distributive property says if you are multiplying some number by a sum, you can distribute or multiply that number by each piece of the sum and then do the addition. So for example, in part D, if I want to use the distributive property, that means I can take the 3 times the 4x, and then I can take the 3 times the 6. So when you have sums or differences, you can multiply each piece by that 3. So let's see, in this case, that would be 12x plus 18. And those aren't like terms. The 12 has an x with it, the 18 doesn't, so you cannot go any further with that. Same with part E. This is also a problem where we can use the distributive property. That means we can take the negative 2 times the x, and then we would take the negative 2 times, I'm going to think of that as a minus 4, and that would give us negative 2x, and a minus 2 times a minus 4 would become a plus 8. Notice that when you distribute a negative number, that actually ends up changing the sign. Multiplying by a negative always changes signs. So putting this all together, if we're asked to simplify algebraic expressions, that means we are going to get rid of the parentheses, so that's using that distributive property, and then we're going to combine like terms. So let's look at 4a. First thing I'm going to do is get rid of parentheses by distributing the 4 and then distributing the 3. So that gives me 4x plus 2 times 4 is 8, plus, and then I have to distribute the 3. 3 times 2 is 6, so 6x, and then it'll be a minus 15. 3 times 5 is 15. After I distribute, get rid of parentheses, I look for like terms, and I can add the 4x and the 6x. That gives me 10x. And then I can also add the plus 8 and the minus 15. Opposite sign, so I subtract. 15 minus 8 is 7, and that's going to be a negative 7. I can't go any further. The 10x and the minus 7 are not like terms. So let's do one more example that's similar. To simplify, I would distribute first, get rid of parentheses first. So 3 times 2x is 6x, and then we're going to have a plus 3y. And now I'm going to distribute, I'm going to think of this as a minus 2. I have to distribute that negative as well. So minus 2 times x, and then minus 2 times minus 4y should be a plus 8y. Again, notice that the signs change when you distribute a negative number. The other thing that I'm doing here is I'm always thinking of that subtraction. I kind of think of it in my head as a negative sign that's attached to the number behind it. All right, so to finish this problem, we combine like terms. I can add the x's together. 6x minus 2x is 4x. And then I can add the y's. 3 plus 8 is 11, so plus 11y. And again, those aren't like terms, so we can't go any